Good evening, welcome to the STEM Shed, your source for your below average tutoring needs. So today I'm going to be going over, and this is going to be in multiple videos, and this will be going over the science behind how air conditioners work. So instead of going through a big house one, I have this portable one right here, which I've used for about a year. My wife and I didn't have air conditioning for many years, so we use these later on. And the way this thing works is, again, this is a portable unit. This is what it looks like. It's also about to be for sale, so if you'd like to buy it, let me know. So to use one of these, you have to hook this tube up to it. You need to make sure it's clear, it's away from the walls, windows, and that's somewhere in a room that needs to be cooled. So, as you can see, using this heat gun here, this shows the room to be at roughly 62, 63 degrees, somewhere in there. It's probably actually a little bit warmer. It's just how these things read. These temp guns are not the most accurate things. It's why they don't use them for your head. You need to take a temperature for COVID. Alright, so I set this low since the rooms are air conditioned, so it actually worked. So as you can see, there's a few parts to it. Now the air is coming out of here. In fact, with this thermometer on there, show that it's going to go down temperature wise. Pressure right here, we go 48 to 30. It's cold. Alright. You have back here, maybe it'll show through here. Maybe not. I'll have to go on the outside and do that one. But you'll see you have a suction right, or what feels like suction. If you actually put your hand here, you'll feel like there's wind blowing on the top side, but it's actually not. This is taking energy in from your hand, and that's what gives you that cooling effect. And if you're unsure how, the paper's stuck. And don't do that for too long because it'll stress out the motor. So I'm going to go over the components later on. I'm going to take this apart, show you the components of how this works, and also why you have to have this on to work. You have to put this thing, it needs to go outside to work. So this thing has been great to us, and hopefully it'll just hopefully it'll bring someone else happiness. Not having AC is terrible. Yeah, look at that. 31, 30. It is getting cold. Yeah, there we go. Going down. So, yep. Still going down. Below freezing. So you might be wondering why you have that big ugly thing that goes out the window. And the thing is, that's pertinent to air conditioning. So, I'll be explaining the Brayton cycle and stuff in other videos, but here's the thing to know. Alright, so you got this gun here. It's 32 out there. Let's see what it looks like in here. Wow. Toasty. So what's happening is the fan's pushing the hot air out here, and as it comes out here, because it's cooler here, because out here itself is showing it at not quite that, but has to work its way down. It's probably in the 70s right now, somewhere in there, high 70s. But that's how it works, because that's hotter. That right there is hotter than it is right here. So the air that's coming out here is transferring energy to the air out here. So it's actually warming up out here. But because, as we discussed about the infinite reservoirs and stuff, this earth is so much bigger than me, this influence is minimal. Now add in a ton of these air conditioners, like on every single house, that can have a warming effect on the earth, which that is what's been up for debate for many years, and I'm not going to get into that discussion because I'm not even fully prepared to understand it. Now here's a question: what would happen if I took this off right here? You can see right here, it is cold. Right here, it's probably showing, see, it's not bad because it's insulated. This will become bacteria adiabatic. It's not so hot that it's transferring through this plastic. However, what if I took this off? Would this room get colder? Would it get hotter? There's lots of questions to ask, or we can try it. Alright, so I took this off. You can see that the air is blowing on that curtain right there. Alright. It is still blowing out cold. Let's see. blowing out cold. But what about over here? Let's see what this shows. This will give a max on, so you find out. 116. My feet are warm. I'm chilly up here. Well, if you're blowing hot air into here and cold air, you're doing work for nothing. It's going to be the exact same. The work's going to balance out. The internal energy in this room, assuming it's fully isolated, is going to remain the same. So what I have here are the video or the footage you saw earlier was me demonstrating how this one worked. And then I had this other one here. This was the first one we got. Both are LG. And we got this, and we had this upstairs, and so we had it up there, and then we used to keep one in the window here, and then we used to keep another one in the living room, and they did really well. I mean, they kept us very cool throughout the summers, or as cool as we can get for a 1,200 square foot house, which has high ceilings. Anyways, but I wanted to take it apart and demonstrate. So I haven't done this video yet, but I'm going to do this one where I have essentially a chart or a diagram of how an air conditioning unit works. This I here drew for a outside unit, one you have inside your home or apartment. But this, the concept still works the same. It's just different components. So I already kind of have it pre-assembled. So you can see this is where the air would come out, and you pull this off as gently as you can without getting things stuck, which I just did. Oh, there we go. Chaos. All right, so took the front off. That was the front. And then keep in mind, here's the back. So this is where the air goes in. This is where the air goes out. And this is just to allow, I think, ventilation in here. So as you can see, I got my fan down. All right, so you can see this here's a blower. This is going to blow the hot air out. We saw it was kicking 112, 115 degrees. Notice how well this thing spins. That has some excellent bearings. That's important. A lot of times stuff like this is what you pay for. If you're an engineer, you're going to have to balance between having the bearings that could go on a Formula One and the bearings from a 1942 Panzer. So, all right. So let's go over here. This is the compressor. It took me a little bit to figure this out, but this right here is the compressor. It's big. It takes a lot of electricity. And then over here, in fact, let me go over this right here. So you can envision this as two separate pieces the same way your air conditioning is two separate pieces. So this is outside, and this is a condenser. So this is what's going to cool that hot air and make it where you can actually, or cool your gas, your liquid in your gas. And then it'll expand and come into here, and then that's all that fun right there. So with everything off, you can see right here is that, let me give it a little spin around. So you might notice there's almost like two levels. This is a tray right here, then you have a tray down there. And we remember this was the intake right here. This is where the air comes in. So you have a blower right here that's blowing air out here. And a lot of times people are confused because they think it's kind of this, that the actual air conditioner unit, the compressor you see outside, and I thought this for a long time, was blowing like cold air that was going to get blown out. I didn't realize it was just recirculating gas and liquid. So all this right here is by itself. You could basically pick this up, move it off on a separate thing, and it'll do the exact same job. If you can extend the piping, you could run it like a normal air conditioner. It just wouldn't be really powerful enough to go through your whole house as a central air conditioning unit. But can you see this right here? So this right here is the evaporator. So people think evaporator, it's hot, it's going to, you think if you hit water on this, it would go psh, steam. That's not the evaporation we're thinking of. It's evaporator because the gas in here, which I think I figured it out, that this right here is the return. So this gas going in and it expands right here. So there should be an expansion valve, but I think not all units have them. They might be controlled enough where they can just widen this. So as this widens, the pressure drops and it will become a gas. As it goes through here, this will be a liquid, but very low pressure liquid. It'll be at the boiling point. Once it goes into here, as this warm air comes into here, it's going to boil it. It's going to increase the entropy and pull it all the way through here, which is going to make this very cold because it's going to take all the heat out, and it's going to blow up cold air here, and then the heat from the warm air here is going to hit that cold air, and it's going to absorb energy, and it's going to recycle. And that's how that works. All right, so as you come down, here's the compressor. So this is the heart of the whole air conditioning unit. This right here, I think, is just a reservoir. I think it takes excess liquid. This right here is the condenser. So they call it a condenser because remember, when it goes through here, this is going to be warm gas coming through here. All right, so as it goes into here, as this pulls air through it, which is actually, yeah, that's what that little thing was for, because it pulls air through here. It's going to pull air through here and blow the warm air out because, remember, this right here superheated this gas. It superheated it, so it's really hot going in, and then it's going to come out through here, cooled, relatively cold, and then it'll go back up there and expand and become really, really cold. And so that's the basis of how all this works. All right, so you can see I have this partially connected. I believe this right here is probably a thermostat, let you know what the temperature is, because I keep it right here. This right here is connecting the computer electricity part. I'm not really a computer guy. And then and this is what gives it power. So it controls everything, gives it power. So I'm going to plug this in, and we're going to see using this if I can confirm what I thought. All right, so as you can see, it's on. I have it set to 60. You can see that fan's moving to see what I'm blowing out here. It may not blow up much. It's going up though. You can see it's warming. 71, 68. Well, here, blowing cooler. 250 is going down. So here's the compressor. Let's see what the compressor shows. Now you can tell these are kind of quiet. Yeah, I can feel it warm in here. All right, let's see if I can get some pipe temperatures. In fact, let's get the temperature right here. Get off the Celsius. To America. So, you can see how it's really cool down here. Ooh, look, right there. Look at that. See that frosting? Yep, that shows that this is where it's expanding. It's a cool gas right here. Maybe I can get some. And then right here, it drops. So that is cold. Yep. So that is where it's expanding. That's amazing. And then it comes out here, relatively just room temperature. It's cool. I wouldn't say ridiculous. I should have got a thermocouple. But as it comes through here, that's not hot. That's just me. Now, let's go look at this right here. A little bit hotter. Yeah, I can feel the warmth right here. This is super heated gas. So I can feel how it's getting warm right there. And let's see, right here. And right here, it's a little bit cooler. It feels like I left in room temperature. Here it's hot. Here it's room temperature. And so yeah, this is going up here at room temperature into here, and then bam, this is where it gets cold. And that cold translates to up here. So as you can see, following my diagram, before I even turned this thing on, I was able to understand what was going on. So here is the compressor. All right, that's the compressor. With that compressor, let's see this side. Oh yeah, so this here is returning. So this right here, coming from this condenser, is going down here, up through here, down here. I'm guessing this is reservoir. Feels a little cool. Comes into here. This thing's getting warm, and then you can't really see it, but that little thing right there goes out. So that's the superheated part we felt right here, going into the condenser, going through all these fins, large surface area, cooling down as the blower moves air through it. Goes down through here, comes out here just relatively fine, and then that's where it goes up into the evaporator and evaporates And that's how your AC works.